All right, good afternoon or morning or evening or whenever you're watching this. In this video, we're going to do 1.16 together. So you need to have your book open. You're going to use page 91 through 93. And once you write down everything we're doing, you're going to upload your work or print out the pages you need. Okay, so this section is going to really focus on percents. So you're going to want to have a calculator handy as well. Percentages are used often in daily life because they scale a situation to 100. Percent means per hundred, an easy quantity to grasp. Percents also allow for convenient comparisons. However, since it's easy to misinterpret percentages, care must be taken. A husband and wife are working together to lose weight. After the first week, they weigh in and compare their results. When completing the percent column, use your calculator for the husband's information, but not for the wife's. All right, so we have the husband. His starting weight was 380 pounds, and his ending weight was 366. So how many pounds did he lose? Well, to find that, we're going to subtract, right? So we're going to take 380, subtract 366, and he lost 14 pounds. All right, good job. Now the percent of weight loss, the way we're going to find the percent of weight loss is you take how much weight that he lost. He lost 14 pounds out of his original weight of 380. So if we take 14 divided by 380, this is where you need your calculator. 14 divided by 380. I'm going to write down everything that's on my screen, and then we can talk about how to interpret this. 0.03684211053. Okay, so the way I got this again, this fraction bar means divide. So I punched in 14 divided by 380. Now if I want to write this as a percent, I'm going to move the decimal 2 places this way. It's going to go right there. And it doesn't really tell us how to round it here, so let's round to 1 place after the decimal. So I'm going to cut it off right here. This 8 is bigger than 5, so that means it's going to round that 6 up to a 7. So I'm going to call this 3.7%. That's how much weight that he lost, 3.7% of his original weight. All right, go ahead and pause the video and do it, the computations for the wife, and then start the video when you're done. All right, so you should have got that the wife lost 10 pounds, and then we take 10 divided by 200. That's a 200 right there. It kind of looks like something else. And you get 0.2 on your calculator. So to change this to a percent, remember we're still going to move the decimal 2 places. There's no digit here, so we put a 0. Oh, wait. I think I wrote that down wrong. Let's do this again. That's not what I got on my calculator. I got 0.05. I think I was looking at something different. Scared you there for a minute, didn't I? I'm just making you feel confident. Okay, so now if I move the decimal 2 places, I get 5, and I'm not going to round to the 10th of a percent like I did here because I don't have any more numbers. So I just say 5. I guess I could say 5.0% if I really wanted to put a digit after the decimal. So looking at it, you might say, well, the husband did better. He lost more weight. He lost 14 pounds. The wife only lost 10. But the husband lost less percent than the wife. Right? The husband probably has more weight to lose. So she, I would say, did a quote-unquote, she would win the week if they were having a competition. You'd want to do it by percent to see who the winner would be. So how do we do this now to find the percent? What do we do to find this actual percent? Well, the first thing we did was we had to subtract. Because we had to subtract to find this number right here. Remember, this 10 was the number we used there. And then after we subtracted, then we divided. Now, technically, to change to a percent, we move the decimal 2 places. That's another way to do that is to think about multiplying by 100. So technically, when we moved the decimal 2 places, we multiplied by 100 as well. And those are all the operations in the order that we did to get the result. All right, and so what we have here is what we're going to call, and we're going to look at this in an example coming up, is a percent decrease. All right, so we would say that the wife's weight decreased by 5%, and the husband's weight decreased by 3.7%. So we could either say that they decreased by these amounts, or if we wanted to, we could put a negative in there, but I don't think we're going to worry about negatives too much just yet. We're just going to say that it decreased. All right, let's look at number 3. So I want you to pause the video and read through these and determine which of the following statements are true and circle the true statements, and then restart the video when you are ready. All right, let's talk about these. The husband lost more pounds. Well, yeah, that's true, because he lost 14, she only lost 10. That's true. Okay, that's not too hard. The wife lost a greater percentage. That's true too, right? Her percentage was more than the husband's. The wife's new weight is 95% of what it was originally. Okay, let's think about this. Well, she lost 5%. So let's say this bar graph represents the wife's weight. Okay, and this would be like 0 pounds, and this would be like 200 pounds. That's where she started, right? And then she got down to 190. And so this part up here, this was 5% that she lost. This is 5% of this total bar graph. So how much weight does she have left from her original 200 pounds? That has to be 95% so that those add up to be 100. So her new weight is 95% of the original 200 pounds. Right? That's true. The wife's starting weight was 5% more than her ending weight. The wife's starting weight was 5% more than her ending weight. Let's see. Let's see. Her starting weight was 200. Is 200, this is really the question here, is 200 5% more than her ending weight, which is 190? Is 205% more than 190? You know what? That's going to turn out to not be true. And we're going to look at an example that goes through the computation and shows why this isn't true. But let's go ahead and look at it here with these numbers as well. So let's just focus on this. What is 5% more than 190? So when we're talking about 5% in this context, and we say 5% more than 190, we mean 5% of 190. So if I took 190 and multiplied that by 5%, or 0.05, okay, you can punch that into your calculator, 190 times 0.05 is 9.5. So 5% more than 190 would be 190 plus 9.5, which is 199.5, not quite 200. All right, so going down by 5% is not going to be the same as going up by 5% because it's 5% of a different number. The 5% she lost is 5% of 200. The 5% more than her ending weight is 5% of 190. So those aren't going to be the same number because you're taking 5% of two different numbers. All right, let's go look at number 4. I'm going to go ahead and pause the video and read through this example. All right, so he went from 200 clients to 250 clients. Well, how many clients did he gain? That's pretty straightforward, right? He gained 50 clients. Is that good? Is that a lot? Did he do great? If I just told you some guy gained 50 clients, Well, it depends. If he started with 10 clients and he gained 50 clients, that'd be amazing. If a person started with 1,000 clients and gained 50 clients, you'd be like, yeah, that's pretty good. If a person had 2 million clients, Twitter, Amazon, I don't know, they probably got a billion, I don't know, clients, and they added 50 clients, it's nothing. So it's really percents help us put things in perspective. So what we would want to do here to get perspective on this is to find the percent of clients added. This is kind of like if someone gained weight, if they went from 200 pounds to 250 pounds, right? So we would say, well, he gained 50 clients out of an original 200. So if I punch this into my calculator, I get 0.25. Move the decimal 2 places is going to be 25%. Remember, you're always dividing by the starting value. So he started with 200 clients. So you're going to divide by 200. So this is a 25% increase in clients. That's pretty good, I would say. That's a pretty large percent increase. So on page 92, this kind of sums up the formula of what we've been doing. To find the percent change, you're going to do the subtraction, like we did when we subtracted the weights of the very first problem we did, where we had the husband and the wife and we subtracted their weights. And then we divided by the starting weight. So that's what this formula says right here. Right? You're going to take the final weight, subtract where it started, and always divide by the starting. Initial value means the starting value. And here's a couple examples here. Now here they are using the negatives to show a decrease. So what they're doing when they do the subtraction, if the sales decreased from 100,000 to 75,000, they're subtracting the 75,000 from the 100,000 to say, yeah, the change here is 25,000 clients, but to show it was a loss, or sales, to show it was a loss of 25,000 in sales, they're doing a negative. And then notice here, they're writing this as a negative percent, but over here they're not writing the negative, but they're using the word loss. All right, so if you use a word with it, like let's say I say they had an 11% decrease. If you use the word decrease, don't use the negative. If you want to say the percent change was negative 11%, now you're saying that it was a decrease. So you can use the negative, or you could use a word that means decrease or loss or something like that. Let's look at an example 7. A college has a 30% completion rate, meaning that 30% of all students who start at the college complete the goal they set. The president of the college set a goal of increasing this number by 50%. What will the completion rate goal be as a percentage? So the question is 50% of what? He wants to increase this number by 50%. What number is that he wants to increase by 50%? Well, I'm going to guess it's the only number in this problem, which is this 30% right here. So it kind of helps when you're looking at percents that you're actually going to increase by a certain percent to maybe just change it to the word percent. So change 30% into 30%. So it's almost like $30 or 30 clients or 30 candy bars. And we want to increase this by 50%. So to increase it by 50%, we need to find 50% of 30%. And then add that on. Okay? So we have our 30%. And we're gonna find 50% of that. So we're gonna multiply that by 50%. And that's gonna give us 15%. Half of 30% would be 15%. Now if I'm gonna increase by 50%, I need to take my 30% and add on my 15%, which is my 50% increase. And that's gonna give me 45%. I guess I wrote percent twice. I don't really need to do that. I think this problem's a little bit tricky with all these percent. So let's talk about this one more time. And let's say we have 30 staff members. Okay, let's say we have 30 instructors. And they want to increase the number of instructors by 50%. Increase that number by 50%. We want 50% more instructors. All right, how many instructors would we have? So we would say, well, I've got 30 instructors and 50% of that is 15. That means I need 15 more instructors. So I'll take the 30 instructors I have right now, I'll add on my 15 new instructors, and I have 45 instructors. All right, so same idea up here with this percent. I just didn't want that to get, I didn't spell instructors right, did I? Too confusing. That should be it. I knew that. That wasn't bad spelling. That was just not paying attention. It's hard to talk and write sometimes at the same time. Instructor. There we go. Now, I want to show you a shortcut for this, okay? Instead of doing this in 2 steps, multiplying by 0.5 and then adding it on, you can actually do this in 1 step. If we're increasing by 50%, what we really have is 150% of our instructors. We're going to keep 100% of our instructors, and then we're going to add 50% more, so we're going to have 150% of our original instructors. So if our original instructors were 30, and we multiply that by 150%, that's going to give me 30 times 1.5, and that is 45 instructors. Okay, so that's a little shortcut, and we're going to do that more in the next section. The last problem we want to look in this section is number 8. This is on page, what page are we on here? Page 93. Okay, so pause the video and read through this. Alright, so I'm going to do the first one with you, and then I'm going to have you do the rest of the years by yourself, okay? I'll go through them on the video. I'll have the answers, but I'm going to have you do it yourself. So, okay, starting with 30 grand, we're going to do a 3% raise. So, I want to do this in 2 different ways. I'm going to do the short way, but the long way first, and I'm going to do the short way. I'm going to encourage you to use the short way, okay? So, a 3% raise means she's going to get 3% times 30,000. That's going to be her raise. So if you punch into your calculator 0.3, that's 3% times 30,000. Let's see, I think that's $9,000. Let's punch 0.03 times 30000. $900. Sorry, that would have been 30%, not 3%. $900 raise. Okay, well, if she gets a $900 raise, then her salary is going to be 39,000. Let me write it over here. 39,000 or 30,900. I keep wanting to give her $9,000. She deserves it. I'm saying she, could be he. They deserve it. Okay, that would be the new salary. What's the shortcut, guys? This is really going to come in handy. If you're getting a 3% raise, I'm going to do this in a different color. Your new salary is 103% of your last year's salary. It's 100% because you get your 30,000, but then you get 3% more. So punch into your calculator 1.03 times 30,000. Punch that in. All right, you should get this number, 30,900. I really want you to use this technique on these next parts, okay? Actually, I'm going to help set you up for this 4% raise and then have you do the last 2. So now I'm going to say their salary is 30,900, and then next year they get a 4% raise. So a 4% raise means their salary is going to be 104% of the previous year's salary, which is 30,900. All right, this instructor gets a 4% raise of their previous year's salary, not all the way back 2 years ago, last year's salary. So if we punch in 1.04 times 30,900, let's see what we get. 32,136. Year 3, 32,136. All right, pause the video, figure out year 4, year 5, and then start it. All right, these are the values you should have gotten. So with a 4.5% raise, I'm going to multiply by 104.5%, or 1.045 of the previous year's salary. And get this. Then the next year I'm going to multiply by 105.5%, and I get 33,000. Sorry, this is a 5. I wrote that down wrong. 35. Can't be less, right? It should be going up. 35. 429, and then I rounded the cents up to 14 cents. Now, find the percent increase from the starting salary to the 5th year salary. So the starting salary was 30,000, and the 5th year salary was 35,429.14. So we want to find the percent increase from this number to this number. Remember how we do that? Percent increase. We subtract and divide by the initial value, the starting salary. So we want to know what was the percent increase over these 5 years, over the whole 5 years, not each year, but the whole 5 years. All right, so pause the video, use this formula, and figure out the percent increase from year 1 to year 5. All right, so you should subtract, take whatever number that is, divide by 30,000, and you're going to get this number on your calculator. So to change that to a percent, we're going to move the decimal 2 places. Let's round to the nearest tenth of a percent again. So let's cut it off here. So this 9 is going to round this 0 up to a 1. And we're going to have 18.1% increase. So, can the teacher simply add the percents for each year and conclude she will make 17% more in 4 years? Well, where did that 17% come from? Let's see. We had a 3%, 4. What do we get when we add these up? That's 7, 11 and a half. That half would make 12. So if I add up all these percents, I get 17%. But she didn't end up making 17% more. They didn't end up making 17% more after 5 years. They ended up making 18.1% more. Why is that? Why is that? Why is that? You got it? Because they were making raises on their raises. The first year, they got this $900 raise. The next year, they got a 4% raise. Well, that also included 4% of $900. That was included in their raise. So they actually made a little bit more than 4% of, the original starting number of 30,000. It's kind of like what we call compound interest. You're making interest on your interest. You're making raises on your raises when you're calculating it by a percent. So percents, they're not always simple or intuitive. You might just look at this and go, if I asked you guys, hey, what percent increase did she make from year 1 to year 5? I can guarantee you there's many, many students that would just add up these percents. But percents don't work like that. You really have to stop and think about percents and what they mean. So if I want a percent increase from the starting salary to the 5th year, I have to see what percent it increased in that 5-year period. And it went up like $5,429 out of 30 grand, which is an 18% increase. All right, I hope that helps, and that is concluded our little lesson of 1.16.